Hello, today we are doing the last lesson for Math 1314. It is 4.6 solving systems of equations using matrices. We're also going to look at some other ways to solve them without matrices as well. So let's just jump right in. So this goes over the definition of a system of equations. And you're very capable of reading, so I'm not going to read this to you. I do want to highlight, though, that when you're solving these, you're solving for the variable xy. And so since you're solving for xy, once you find xy, that is a point. And it's actually a point where those equations intersect. So if we wanted to write a system of equations from given information, we would need to make sure that we align our variables with the correct numbers that are being given to us. So this is an example of how to write a system of equations. And again, I'll let you read through this on your own. Now, matrices is a tool that we can use, and matrices are very powerful. They can actually do a lot of things for us, but for today's context, we're using them to solve systems of equations, which can be helpful, especially if you have several variables. So if you're just solving a system of two equations where you're looking for x and y, that's probably pretty simple to do by hand with substitution or elimination. But once you start getting into 3, 4, 5 variables, that becomes very tedious to do by hand. And so using a matrices and a tool like a calculator to help you do that is preferable. So just so you understand the different parts of a matrices, the parts inside the matrices are called the elements of the matrices, but the entire collection of those elements is the actual matrix. So we use augmented matrix to help us solve these systems of equations. So we're taking our systems of equations and putting them into a matrix so that we can use the matrix to be able to solve. So this shows an example of how to write augmented matrices from systems of equations. So usually you'll have some kind of word problem. You change those words into a system of equations, and then once you have a system of equations, you can use that information to help you create an augmented matrices. So if we wanted to write this system of equation as an augmented matrices, we would simply make sure that when we write the matrices, we align the variable coefficients in the same columns. And so for x, we have 45 and 30. For y, we have 200, 2, and 10. For z, we have 400, 4, and 300. And then we're going to put the solutions that they're equal to. When we write them by hand, we put that line there so we realize they're solutions. If you're doing it in a calculator, obviously that line's not there. So you just have to realize that you're saving that last column for the solutions to those equations. So that is how we write a system of equation into a matrix. Now, in the notes that are provided, it tells you step by step how to solve these equations with a matrices using a TI-84 calculator. And that is very helpful because TI-84 has been used for several years and is the most common calculator that is publicized and used. But today, when I demonstrate, I'm going to be using the NewsWorks calculator because I prefer that calculator, and it is really simple when it comes to solving these equations. So it's a very powerful tool, and it's cost effective in comparison to a TI-84. If you do not have a NUMSWORK calculator and you want to use NUMSWORK, because that's how I'm showing it here, NUMSWORK has a free calculator simulator that you can download to your computer, or you can use it online. So I've gone ahead and downloaded it to my computer, but if you wanted to use it online, you would just go to numsworks.com and find their emulator. So the big key when we are doing this is to get it in reduced row echelon form. And it's a long process to do it by hand, to change a matrices to reduced row echelon form, where the main diagonal is 1 and then everything else is zeros except for your answer column. And that answer column actually gives you the solution. So the way to do this by hand is time consuming and tedious, and that's why we use calculators a lot of the time to do it for us. And most calculators have a reduced row echelon form command if it is a more advanced calculator like NUMSWORK or TI-84. So again, these are TI-84 instructions to tell you how to do that reduced row echelon form in the TI-84. And you can read through these. They're really straightforward, but I'm going to use NUMSWORK when we get to an example. So this is showing the one we just did, what it reduces to when you do row echelon in the calculator. So let's just do this one just because we see the answer here, and we can go ahead and do that. So I'm going to pull up that calculator. So we have a calculator here. If we're doing it with matrices, we're going to enter the calculation portion. So that's the portion that looks like this. You can highlight it by moving your arrows. So then you click OK. Now, once we're here, we need to first create the matrices. We can do that by clicking this toolbox right here. So on the smaller calculator, the toolbox right here, it's right next to the clear button. When we click that, we can use our arrows to go down and find matrices and vectors. Once matrices and vectors are highlighted, you're going to click Enter. And then we're going to create a new matrice or a vector. So we're going to click Enter again. Now, it looks like it's only a 4x4, but as you start typing, you will see that it will expand for you until you have the desired size for your matrices. So for this matrices here, let's go ahead and work on it. So 400, 5, and 30 were our x values. So then 200, 2, and 10 were our y values. And then 400, 4, and 300 were our z values. And then the solution, which when we did it by hand, we put a line there, is 660, 25, and 45. And then once we have it in there, we're going to click Enter. So it does just have that 3x4 matrices there. So once we do that, we can now go back and click that toolbox again. And you see it's still on matrices and vectors. So we can scroll down until we see matrices and then click Enter. And then we're going to scroll down until we see our ref, which is reduced row echelon form, and you can see that's written out here right there. So we can click Enter. Once we do that, it needs us to put something in. Since we already typed our matrix, we can just click the up button and highlight that matrix and click Enter, and it fills it in automatically for us. And then we can click Enter again, and it gives us a solution. But that's not the right solution. So I think I must have made a mistake when typing. Let's go back up and look. 660, 20. Yep, you see that 45? That is not the correct number. So let me go and click enter again. And I'm just going to go in and edit that. And so it's 425. So this is great that I made that mistake, so you can be reminded. Always check your work and make sure that you are doing what the problem said. I missed when I was typing a number, and so I did not get the correct answer. So now we'll click enter again. What is happening? Why is that still wrong? Oh, because I put 400. Man, I just really messed this one up, didn't I, guys? So I'm going to go in here and double check all my numbers again, because this was supposed to be 40. So it's 40, 5, 30, 200, 2, 10, 400, 4, 300, 660, 25, and 425. Ooh, it is right this time. All right, and you see we do get the answers that we had in our notes, which were 4, 1/2, and 1. So again, it's really easy to input incorrectly, and that's why you want to show as much work when you're working on a test so that I know what you intended, even if you get the wrong answer. That will let me know that you knew what you were supposed to do, but you just miscalculated in some form or fashion. All right, let's take a look at the next one. So use a calculator to solve the system of equations. And so again, we're going to use NumWorks because we have been doing that, but let's go ahead and use write our augmented matrix. So you can practice writing that on your paper before doing it in your calculator. So our augmented matrix here, we're using the coefficients. So since there's not a coefficient, we know that coefficient there in X is 1, 3, and I didn't make my matrices big enough. So we have 1, 3, and 8 for our X values. For our Y values, we have 2, -5. You want to make sure you include the sign. And 1 again, because we have this one here. And then we have 2, 4, and because this is blank, we know that's plus 0z, so we're going to put 0 there. And then we have -9, -64, and -3. And so that's the matrices we need to create in our calculator. So I'm going to go back over to my calculator simulator. And I'm going to do a fresh one this time. So I'm going to go back and I'm going to click the toolbox again. I'm going to go up to create a new matrix. Let's see, let's go back out. So I click this arrow button here to go back out of the matrix commands. So now a new matrices, I'm going to click enter. And so I'm going to input what we just wrote. So we had 1, 3, and 8. Y'all double check my work here because after earlier, I feel like I'm prone to mistakes. 2, -5, and 1. Then we have 2, 4, and 0. And then we have -9, -64, and -3. So again, just double check your work. Make sure that you input it correctly. I'm looking over it to make sure I did, and I feel confident I did it correctly this time. All right, so now we can click that. We can click enter, so it's there for us, and click the toolbox again. Click down to matrix and click enter, and then click down to reduce row echelon form, RREF, and click enter, and then click up to highlight that matrices. Click enter and enter again. And we see here we get the solution -1, 5, and -9. So when I go to write that answer on my paper, I'm going to write that I got X equals -1, y equals 5 and z equals -9, or I can write it as a point, and so that point would be -1, 5, -9. So this one says solve the following system using Gauss-Jordan elimination. So elimination is a way we can do it by hand. And of course, you can always check it in the calculator after you do it by hand. But I do want to see you attempting to do these by hand so you have good practice with Gauss-Jordan elimination. So for elimination, the big thing is to get rid of one of the variables by multiplying the whole equation by a particular number that will help you get rid of that. And here, if I have 3 and 2, I'm going to have to multiply both of those by something. I don't really want to do that. So I'm going to use y to try to get rid of. And since I have a -3 here, I'm going to multiply by +3 to this entire equation so that I can get a +3 here. So this first equation I'm going to leave alone and just bring it right over exactly as is. And this second equation, I'm going to apply the multiplication. So I have 6x plus 3y equals 9. Now I can add these two equations together. When I do, I get 9x. Here, the y cancels because I have -3 and +3 equals 27 plus 9 would give me 36. And now I can divide both sides by 9, and that gives me x is equal to 4. Once I have x is equal to 4, I can substitute that into either of the original equations, and that will give us the y. So if I use 3 times 4 minus 3y equals 27, I get 12 minus 3y equals 27. I can subtract 12 from both sides. I get -3y equals 15. And then if I divide both sides by 3, I get y equals -3. Let's divide by -3. -5. So our solutions are x equals 4 and y equals -5, or if you write it as a point, the point 4, -5. So we can solve the following using Gauss-Jordan elimination as well. So we're going to do this one. This time I see that I have a 2y and a 2y here. I'm just going to multiply one of these by -1 to make one of them negative. So I'm going to multiply this first equation by -1. So then I get +x minus 2y equals -4. And then the other equation, I'm just going to bring it over exactly as it appears. So then here we get x minus 6x, which will give us -5x. The y cancels. -4 minus 6, so that's really saying -4 plus -6, so that'll give us -10. Divide both sides by -5 to give us x equals +2. Now we can substitute into either of the first equations. I'm just going to do the original equation of -2 plus 2y equals 4. So I can add 2 to both sides, and I get 2y equals 6. Divide by 2 on both sides, and I get y equals 3. So I now have the point 2, 3. This last one, we can also use the Gauss-Jordan elimination, and I want you to practice this one on your own. So pause the video and go ahead and practice this one. Okay, hopefully you followed those instructions and you paused the video and practiced. I am also going to show you in NumWorks how you can use the equation function to solve these because it's a nice tool in this calculator. It doesn't use the matrices, which you can use, but it uses a different function built into this particular calculator. So I'm going to go back to the calculator and I'm going to click the home button. And then I'm going to go over to where it says equations and click enter. And then add an equation is already highlighted. I'm going to click enter. And I'm going to enter an empty one so I can type my equation here. So you can type your equation, 6x. And if you don't know where x is on the calculator, it's right here. Okay. 6x minus 3y. You could click this a second time, twice, and it would give you n instead of x, and you could use that. Or you could click alpha 3 to get a y if you want that. Equals 0. And then I'm going to click OK and go down to add another equation and click OK and empty again. So I'm going to click OK. So now I'm going to type the second equation. So x plus 2y equals 5. And then I'm going to click OK. So this is my system of equations. And then I can take my pointer and go down to highlight solve the system and click enter. And when I do, I get that my x is 1 and my y is 2. So that's a really nice function of this calculator, and one of the reasons why I am preferring this calculator lately over the TI-84 model. So if you did this one by hand, you could have done it several different ways, but regardless, you should have gotten that x is equal to 1 and y equal to 2, or the 0.12 as your solution. And that is the end of Math 1314. So great job. We've made it all the way through the required college algebra information for any college algebra course. So I am glad that you joined me for this course. And if you ever need assistance or have individual questions, remember you can always email me at my email that's attached to this YouTube account, or at cjacobs@mtcc.edu. Thank you.